Hi, my name is Max Schafer, and this is the DP2 presentation for Team 8. Our product is the ErgoLift Lite, and it is a laptop stand. Okay, so the agenda for this presentation, we're going to go over some background and overview of our product. Then we're going to go through the concept generation, design selection process, and then finally we're going to wrap it up with some information about what our next steps are, how we're going to finish this whole process up, and have a functional prototype in the classroom by the end of the semester. Okay, so our key demographic, our customer profile, is a health-conscious, hardworking student that needs to be able to study on the go. Oftentimes, studying on campus, you don't have an ideal situation for ergonomics, and so you have to be able to study wherever you need to. Oftentimes it's on the floor, or it's studying on your lap, or in a small dinky table in a hallway. The idea for this product is that it allows you to bring ergonomics with you. Any of those situations could be adapted to be more beneficial for you health-wise than just having your laptop wherever it may sit. But yeah, so the idea for this is to make studying on the go healthy for not only your body but also your mind. Okay, so we have one main constraint, which is size. It needs to be the product, our ErgoLift Lite, needs to be about 8.5 by 11. We want it to be the size of a notebook, so it easily fits into a backpack. And then it needs to be able to be light enough that it's not a hindrance for a student carrying it. Okay, so the main three features we want to have is we want it to be able to lift, we need it to be able to tilt, which is better for ergonomics, both of those, and then ideally we would like to incorporate some type of ventilation into it so that we can increase the performance of the computer as well, which just means adding some type of cutouts in the top, gives some more breathability to the computer. Okay, so we came up with several different designs. Our most successful design creation process was the concept combination table. We came up with several designs, which I'll go through now. The first was legs, magnets, and rubber pads. The idea behind this is that it'd be really collapsible, but it had a lot of pieces. It was very intricate, and a lot of the pieces were really small and delicate. So we really didn't think this would be a good way to go forward, judged on our concept selection process. This one scored kind of low. The next one is the red line here, which is unfold notches and clips. Similar to the last one, it kind of has a lot of little intricate pieces. We couldn't find clips online that would fit our use case very well, and we weren't sure how to manufacture those in a way that it could be adaptable to multiple computers, especially with the rather low tolerances that you get with 3D printers, which is probably what we're going to have to use to manufacture this product. Okay, so we decided to move away from clips in general because, like I said, they're really hard to find or manufacture. But yeah, so anyway, this design was good, but it had too many small pieces. So moving on to the next one, we have the purple line, which is unfold set screws and rubber pads. This one again collapsed really small and would end up, the size of like a pair of drumsticks essentially. The problem with it again is that it has a lot of really small delicate pieces, and the backpack of a student is not the safest environment for delicate things, so we thought that this probably wouldn't survive very well, so we moved away from this idea. The next one is the blue line, which is scissor lift, notches, and lip. The idea behind this one is you have two scissor lifts that are on opposite sides, front and back of the product, and you could adjust those scissor lifts to different varying degrees, which would give you lots of height, and it would also allow you to tilt the computer however you wanted it for your ergonomic needs. The problem we have with this one is that it needed a flat surface to sit on. It was also very complex to try and get all those moving parts into one to one compact design. So we moved away from that. The next design is the yellow line, which is leg, set screws, and lip. This was a very, very simple design, basically the other end of the spectrum from everything we've seen so far. But it was too simple, and it didn't allow for enough variability. The only being able to tilt, there's no real lifting in this thing, so we wanted to make sure we hit all those main three tilt, lift, and ventilate design constraints. And then finally, we had the purple line, which is unfold set screws and rubber pads. This one ended up being the closest to the design we ended up going with. The only main difference between it and the next one is set screws. Set screws would be interesting to use, but they'd be difficult to implement, and we had concerns about them being strong enough to hold the weight of a laptop, given that they're only functioning on tension. Especially if you're typing on them as well, you have the additional weight of your hands and the pressure of typing. Okay, so a new design we came up with is this blue line down here, S-foil notches and lip. The S-foil notches and flip are an ideal combination because it adds all of the variability in height and tilt that come with the last design we went over, but it allows for more rigid, permanent stands on there to really support the structure when we're working on it. So this was the design we submitted in our gallery method presentation to the other team. The main feedback we got were feedback from modifications we got was that the design needed more ventilation, and we also needed it to have more supports so that it'd be a little bit sturdy, a little bit stronger. Yeah, so this is our final design. As you can see, we enlarged the VT logo, make some hokey support there, really appeal to our target audience, which is supposed to be Virginia Tech students. We beefed up this bottom support, and we added another support on the top to make those symmetrical. The problem we were having is a little bit wobbly. But yeah, so this is our final design that we're going to go forward. Over Thanksgiving break, a team member and I will be going up to Northern Virginia. The libraries there have a robust maker space that allows you to 3D print basically whatever you want as long as you pay for filament. And so we're going to go up and we're going to try and print this whole thing over Thanksgiving break so that we can have it back in the classroom ready to go at the end of the semester. But yeah, so this is our design. We're really excited about it. It should be pretty interesting once we get it printed and we're able to actually work with it. But yeah, any questions? Cool. Thank you. My name is Max again, and this has been the DP2 presentation for Team 8.